Hi everyone, how are you doing? I'm just gonna shake hands with this guy. I remember this guy from a PHP conference in Mohochice Kapitulnie here in Poland. I remember, thank you for attending. This talk is called Cache Rules Everything Around Me. It's about caching, obviously. I have the little bit of a Wu-Tang Clan thing going on. Let's see if you can hear it. Yeah, you can hear it a bit. So cache rules everything around me. There's a lot of people in here. I have a hard time seeing you right now because of the lighting, but Mike asked me to, if you have any questions, just tweet them, use the hashtag Infoshare and the hashtag tech, and you'll be just fine. Just a quick disclaimer, this is a 25 to 30 minute talk, and have an extended version of this very presentation coming up at the Tech Plus stage at 2 p.m. So if you're interested, stop by. It's a 90-minute talk. We'll dive deeper into all the bits and pieces. Without any further ado, hi, my name is Thijs. I am Thijs Feryn on Twitter. I think I'm just 6 followers short of 3,000, so if 6 of you could just follow me, I'd be absolutely delighted. I'm a tech evangelist at a web hosting company in Belgium called Combell, and in my spare time, if I have any, I am a board member at PHPBenelux, which is the PHP community in Belgium, the Netherlands, and Luxembourg. So let's dive straight in, because we have a limited amount of time. This is something you'll probably agree with, right? Slow websites suck, right? Yeah? Sure? Okay. And we have realized by now that web performance is an essential part of the user experience. A user that goes to a website and it's slow, he'll just abandon that website, go someplace else. And we need to figure out why this is caused so we can solve it. And there's a variety of reasons. Reason number one, you have poor infrastructure. That starts with connectivity. If your network is crap, hey, your website might be slow. If the servers are bad, servers are under-dimensioned, so not enough RAM, slow disks, not enough CPU, all that stuff could have an impact on the end result. A big part, and that's a big part of my day-to-day, is looking at other people's crappy code. I work at a web hosting company, and a lot of people have no clue how to write code efficiently or how to make a good software architecture that scales along. This is a common one. The database is often the slowest part of your application. So slow databases could cause that. And even if you write top-notch server-side code and your infrastructure is fine, you might end up with browser rendering issues. That's not quite my department. I'm not a front-end expert. There's plenty of those in here. But that might be one of the reasons. And a final reason that I could think of is user location. You have your user base, let's say in Europe, and you host in the US, and there's a bit of latency, and you're using high-res images or high-res video, and that kind of screws with the punch this has. If you're across the Atlantic or across the Pacific, there will be some minor delays. Keep that in mind. And in that respect, you might want to consider a CDN. So essentially, a slow website is just as bad as a website that is down. If your website takes 2, 3, 4, or 5 seconds to load, it will feel a bit slower. Sometimes even 10 seconds may seem like the entire thing is down. So what we're going to do is today, in this short amount of time, and later on, during my 90-minute track, is identify the slowest parts and figure out ways how to deal with that. A thing we could do, if you have time, money, and the expertise, is optimize your code. Would be a big one, a huge one. Optimizing the database is a no-brainer. Checking out if you're using an SQL database, an RDBMS, looking at the indexes, looking at the hit rate of your indexes, checking out the joins you do, make that better. Another thing you could do is optimize the runtime where your code is running on. If you make that one better, or if you could speed that up a notch, that will definitely help you. But the sad part of all of this is, after a while, you'll hit limits. And you can go beyond those obstacles, but that might cost you too much time, too much money, and you need to figure out a different way to deal with. So instead of optimizing the database or optimizing the runtime, we could just avoid it totally and skip it. And that's where caching comes into play, and that is actually the essence of this presentation. I remember 12 years ago, I graduated from Polytechnic in Belgium, and I remember my database professor told me, hey, don't store things you could recompute, because back in the day, disks were expensive, and you might or don't store any data that you could recompute. And I'm saying the exact opposite right here. Don't recompute data if the actual data hasn't changed. Why access your database? Why do these expensive SQL queries? Why generate I/O wait when the data has not changed? That's something to keep in mind. And that's like the clue of this presentation. And I want you to take this back home. And I'll do a test with you. Let's do a quick one. Let's hop off stage. What's 3 times 2? 6. 6 is the right answer, right? Did you have to think about that? No, it was just there. You cached that in mind. You did that. And that's actually what I'm trying to say here is instead of doing all these computations, and you've seen it here, 3 times 2 is 6. We don't need to think about that. It's already there. And is that a trick he's pulling? Is he pulling out a dirty trick to give me the quick answer? No. It's essential. It's a strategy he's using. So what can we cache? At the bottom level, if you're using an interpreted language like PHP or any other, you might want to optimize the bytecode because that will slow you down. There will be lots of reads from disk to compile those files on the fly and turn it into machine code. Files that you might access from disk might be slow as well. You might want to use a RAM disk or store it in any other mechanism. But the key parts, and those are the green one, the red one, and the yellow one, is database output. We definitely want to cache that because that will cause major slowdown in a lot of cases. When you rely on an external service, could be a RESTful API, SOAP API, anything else, you might want to cache that output as well. And the most trivial part is caching the output, the actual pages, being HTML or XML or your JSON output. So what I'm trying to say here is that caching is not a compensation for poor code. The fact that this gentleman said that 3 times 2 is 6, and he did it on the fly without having to compute it, it's not a compensation. It's an essential strategy. It's an architectural strategy, and respect that. Okay, let's dive a bit deeper and have a look at the toolkit we'll be using today to optimize poor infrastructure, poor codes, and so on and so on. There's 3 tools I'm going to discuss today. My favorite one being Varnish. Anyone has heard of Varnish? A couple, so you might learn a thing or two. Redis, any people know about Redis? More than that, yeah. Elasticsearch. I put an asterisk next to it because it's not really a cache, but we'll be using it. Let's do it. Let's do a quick overview of the technologies. I told you I like Varnish. And you see the superhero here? It's actually the superhero of caching technologies. Under normal circumstances, let's have a look. Your user will be connecting to the server directly, will be requesting pages, will be getting output. If you work with Varnish, there will be a box sitting in between, acting like the server towards the client, and acting like the client towards the actual web server. If you're still confused, look at this one. Who has seen this blockbuster movie of the 90s, The Bodyguard, featuring Kevin Costner and Whitney Houston? Anyone seen this? Yes. Then you notice that Kevin Costner is the bodyguard, and he's trying to protect Whitney Houston from stalky fans. That's exactly what Varnish does. Kevin Costner is Varnish, Whitney Houston is Apache, Nginx, IIS, whatever you use. When you request something, let's say you want an autograph by Whitney Houston, you don't do this directly. You pass through the bodyguard, and if the bodyguard allows you, it'll come in. Otherwise, it won't. And what Varnish does is it stores all of this information, so the request from the backend, it stores this in memory. It keeps it nicely in memory. It uses the latest, or not even the latest, but it uses really smart kernel optimizations in order to handle this quickly and not be suffering under load itself. Varnish can never be your bottleneck. Cool thing is, it respects cache control headers. So if you deal with cache control headers in an efficient way in your application, Varnish will respect those, Varnish will respect time to lives, and if you specify that something is not cacheable, by adding a no cache, a no store, or a private part in the cache control header, Varnish will say, okay, we will not cache this. But the major advantage, and this is huge, is it has its own DSL, the Varnish configuration language, aka VCL. I have some VCL for you here. This is in a file that is loaded, and it does certain things. What I'm doing here is, this is, even if you don't have VCL, this is the default behavior written in VCL, if you know what I mean. It has hooks, so you can't program top-down. You have to hook into the logic. You have to hook into the flow. And we're hooking into the receiving part. So if you receive a request from a client, it will do certain things. In this case, if it sees that you're using the pry method, it's SPDY related, it will just give you a 405. If you're using non-RFC compliant HTTP methods, it will pipe it off. So that means it will open the TCP connection to the backend, and it won't deal with it. In any other cases, if it's a get or a head, it will deal with it. If it's not a get or not a head, so a post, delete, put, patch, It knows that the data will obviously change, because otherwise you wouldn't be calling these methods, and it will pass it to the backend, and on the way up, it will store it in a so-called blacklist to make sure it doesn't get cached. Let's continue. If there's an authorization header or a cookie, that means you're dealing with user-specific data. So that's, in theory, that's not really cacheable, so it won't cache it either. And under all other circumstances, as you can see, it will return hash. And hash means compose a hash key, store or look if you could store it, if it's retrievable from memory. If it's in memory, return it. If not, fetch it from the backend. And we continue. This is where the actual hashing happens. And you can see, if you pay close attention, you can see the actual algorithm that it's using. It will look at the URL and create a hash key out of that. And then next to it, if there is a host, so if you're using an actual host name in your URL, it will use that host as a cache variation. And if not, it will use the server IP. And then it looks it up. So pretty straightforward, right? Hashing, and this is a cool one, backend response. So if you're not hitting your cache and you need to go to the backend, and the backend responds, that will be the logic. And the logic states that if you don't specify a cache control header, or the max age is less or equal than 0 seconds, do not cache. It makes sense. It gives the power back to the application. If it sees a set cookie, so if your backend sets a cookie, that means there's a state change. It means user-specific data, means Varnish won't cache. If it sees a no store, a no cache, or a private header, won't cache either. And so on and so on. This is the default behavior. You can extend that at any given time, because I know you'll be dealing with cookies, and I know Google Analytics will be flooding you with tracking cookies, and there's ways to deal with this. And the details about that, again, as I mentioned before, 2 p.m., Tech Plus stage, upstairs. These are a couple of the features that Varnish is renowned for. So yes, it is a kick-ass, excellent cache. I don't think there's better reverse caching proxies out there, and it's open source, so you don't have to pay for it. It is a fairly decent proxy. So as a proxy, you could deal with what comes in, what comes out, and you can influence that. It does a bit of load balancing, too, so you can connect to backends, to multiple backends, do round robin, do randomization, do URL hashing, so on and so on. Major feature, talk about it in just a minute, are edge side includes. Anyone has heard about, let me have a look, anyone heard about edge side includes? Keep your hands in the air. Do you like edge side includes? Apparently people do, so we'll be discussing more about that. You can stream data. If your data is too big, you could actually stream through binary data. You can do gzipping on the fly. You have a really good and intricate way of doing cache invalidation. There's a module ecosystem where you can extend the behavior by not writing C yourself, but by installing modules that have C libraries included, and it has pretty decent logging tools, so you can see the behavior. You can anticipate what will be cached, why it will be cached, or why it won't be cached. But I was talking about user-specific content and the fact that cookies weren't cached. That's a major issue, because in reality, in your everyday application, it's all about state. You'll use a cookie to keep track of your session, maybe your language. You'll track all that kind of stuff, and cookies are everywhere. So if you write the proper VCL, you could select a couple of URLs where you will say, I'll keep the cookies because they matter there. And in all the other parts, I'll just strip it out. And you can do that in VCL. What you can also do is if you need the cookies and your page effectively becomes uncacheable, you can chop it up in bits and pieces. Now let me show you how that works. This is a typical, yes, I am a PHP guy, I apologize for that. You'll see PHP in the end. Your typical layout, header, footer, menu, main page. And you'll say the header, we won't be caching that because it contains a shopping basket or your logged in information like hello, taste. It will probably be there. The footer, you'll cache it for 5 seconds, main page 2 seconds, menu 10 seconds. It's really hard to do that. But luckily there's edge side includes, so that means it's a bit like old school server side includes, but delivered on the edge. So what Varnish does is it sends you, this is a way of doing this, is some VCL that makes it happen. You send a surrogate capability header with an ESI key as a request header, so you send that to the backend. When the backend responds with a surrogate control header, it's like a two-step communication process. You announce that, hey, I can parse ESI, and the backend says, oh, then I'll be sending you ESI. And when that happens, you render it. And I'll show you how that works with a really simple PHP script. So what you do here is you set a cache control header to no store, so that page won't be cached. And you add the surrogate control content header. And what you do then, this is where the magic happens. You have this ESI include tag. It looks like a regular XML or HTML tag. And you mention the URL that should be loaded in here. That does not happen on the server. The server exposes this as a tag But Varnish is clever enough to interpret it, fetch the stuff, and cache it in a separate cache key. So all of it happens on the edge in your Varnish. And you can put your Varnish where your users is, and so that's actually edge-side caching. This is a way of chopping up your content into blocks and making sure that even non-cacheable parts can be partially cached. This is a major way of doing this. But there's drawbacks. Not a full ESI syntax is supported, and it's still single-threaded, and it doesn't do it in parallel, so if anything breaks, your entire site falls over. So in that respect, a lot of people, I guess that's the case, who uses Ajax here for stateful stuff. Probably a bunch of you, right, using Ajax to load shopping carts, to load user profiles, and so on and so on. Ajax doesn't happen on the edge, so it's not optimized. It depends, or it relies on the browser. But there's this sense of graceful degradation. So if your Ajax request fails, you can deal with that in Ajax, or in JavaScript rather, and make sure that, it's not an issue, there's no error, that block is just not loaded. So essentially, HTTP, or Varnish is an HTTP accelerator. It's more than just a cache. I love it. Let's go to the next one, which is Redis. Entirely different thing. Redis is a key value store. So what that means is basically RAM over the network. So there's a separate box, a separate server. It has some RAM, some shared memory, and you can communicate with it over TCP/IP or Unix sockets. It's blazing fast, it's lightweight, and it's ideal for real-time data, data that changes a lot, but especially volatile data. That data is stored in RAM, but there are persistence options. You can make sure that every now and then a snapshot is made to disk or in case your stuff crashes on you. It's like Memcached. Who's heard of Memcached? Yeah, a couple of people. It's similar to Memcached, but it offers more cloudy features, or more efficient features too. It offers data types. So you can, instead of storing everything as a string, it has the notion of hashes, sets, lists, and so on and so on. And it has replication and clustering, so that's very cloud-friendly. So as mentioned, strings, hashes, lists, sets, sorted sets, even geopoints you can save in there. But it's not for searching. It's not an actual database. It's a key value store. So you give it a key, and it will return the value. Nothing more, nothing less. But if you know your key, this is the fastest way of dealing with it. So setting a key to a value, you can do that. Since it's over the network, you can connect all your web servers to those Redises. And you say, get the key, returns the value. This is way faster than accessing stuff from database. And if the data doesn't change that much, you can store it in Redis. Here's an example of using more complex data types. As you can see, H stands for hash. So you can set a hash called customer1234, and you can set the property ID, and then you can set the property items in cart, and then you can set his first name. So in that way, you can, this is like session data that you could store in your Redis, really fast access, not having to access the database all the time. Same for lists. You can push stuff on a list, pop stuff from the list. These slides will be online, by the way, so you can have a cheat, or you could cheat and have a look at that. So as you can see, Redis is a good way of offloading your database. Next up, and there will be a summary where all of this fits in, is Elasticsearch, my favorite NoSQL database out there, or search engine. It's not really a cache, but it's a full-text search engine, so it's like Solr, a bit like Solr. You can throw all kinds of stuff in it, and it will be indexed, and you can use full-text queries on it, or you can just filter data out. I like it as an analytics engine too, so you could do all sorts of computations on the data sets and get averages. You can get geospatial data. It's really powerful. And I use it as a NoSQL database as well. I know MongoDB is out there. There's similar technologies out there too, but I like Elasticsearch because it does a lot of things. It's based on Lucene, just as Solr is, and it has built-in clustering, built-in sharding, works pretty fine out of the box. And what I particularly like about Elasticsearch is that it has a RESTful interface. That's the only or the main way to interact with Elasticsearch. Everything's a REST call, so that makes it easy to integrate as well. It gives you JSON output, and it's so-called schemaless. It's not really schemaless, but you don't have to worry about the schema itself. So excellent for fast retrieval and also fast search. That's something that Redis can't do. Redis is even a bit faster than Elasticsearch, but Elasticsearch, you can drop queries on it. Rather complicated queries, either full text or just regular queries. And it is all REST. Here's an example. And it fits on screen. What I'm doing here is doing a post call to blog post 6160. So this is some meta information about the blog post I am inserting. This is a way for me to store this in Elasticsearch. It's kind of simple, right? You can use whatever tool you want. It's REST. It has different data types. This is a string. This is a string. this is a date, this is a collection, this is a number. So it deals with that, and you can retrieve it by just doing a get. That's the key value way of doing it. But you can also use a built-in DSL to retrieve data in a rather complicated way. So you could say, I just want a title field, I want a query, I want to look at the title field itself and retrieve all the data that contains working. So have a look at the elastic.co, and I think there's some more Elasticsearch talks throughout the conference. Have a look at them. It is an excellent way of offloading the database. So a reminder for you, where does all of this fit in? These are the things we can cache. Let's have a look. We've discussed the 3 technologies, how you could actually use them or fit them in your project. And that will be the end of the presentation once we covered that. So Varnish, as I mentioned, you can use it. It's excellent at storing static data, like images, JavaScript, CSS. That speeds it up a lot. There's a small remark to that, is do you really want to save all of that in memory? Because an Nginx or a CDN or even Apache is pretty fast. And your slowdown will probably not happen because of static assets. It will happen because of pages rendering, connecting to the database, connecting to the runtime. So what I'm basically saying is, it is excellent for dynamic pages. Things that cause too much resource consumption, use it for that. You can use either ESI or AJAX for user-specific data retrieval. Those AJAX calls can pass through Varnish just as any other request. You can use Varnish as well to sanitize input and output. Gives you a stripped-down version of HTTP. And it is essentially the gateway to your application. Put that one in front of your application servers, let all the data come in, cache where you can. If you don't want to cache, you can optimize data, you can sanitize, you can make stuff more anonymous. Where does Elasticsearch fit in? If we look at it from a more e-commerce perspective, it would be an excellent storage system to store in all your products or your categories, which you can search, which you can filter, which you could do like dig down or like dig in and do all sorts of aggregations on. So that is, for me, the primary way to offload your database for data doesn't change that often. And it's also important for fast retrieval of data projections. Like the cool thing we have with SQL is that you can issue any other SQL command and you could do joins and create a composition of data. Every time you specify a SQL query, it will be a different output. Elasticsearch doesn't really work that way. So if you know the views you're going to create, if you know the output you're going to create with your SQL statements, you can create those projections and store them in there, and those will be way faster. You can still search, you can still filter, but the data set will be pretty much fixed, and it'll be stored in JSON. So that's a good way. So don't do joins, store readily available data. So if you're coming from an e-commerce context, you can offload your products, make sure you don't have to access the RDBMS. But the RDBMS will still remain, or can remain, the source of all truth, so keep that in mind. Where does Redis fit in? Redis is excellent for volatile data and data that changes a lot. So if we look at it again from an e-commerce perspective, that could be your shopping cart information, your user profile, or things that change rapidly, like stock, the amount of stock, or pricing. If you have dynamic pricing, it would fit right in there. And then in the other way, if you just want to add a simple caching layer that can easily expire in front of your database, Redis could do the trick as well. If you come to my workshop at 2 p.m., I have some code examples about that. So that's all the time I have. I have exactly 1 minute and 22, 21, 20 seconds before we end. You can follow me on any other social media. I have a vlog, I have a blog, I have a podcast, I have any other thing. I would like to thank you, and I think you have 5 more minutes for questions?
Actually, we have. However,
okay.
I haven't found any in my app. So probably you will find Thijs.
Yeah, I'll be around. I'll be on site all day. So if you have any questions, don't be afraid to approach me. I'll be very nice to you. I'll try to answer your question as good as I can. That being said, thank you for sticking around, and see you next time. Maybe see you at 2 p.m. Who knows? Cheers.
Thank you, Thijs.